Hello my dear friends, welcome to the YouTube channel Math Skill. Let's learn mathematics together. The aim of this channel is to help students overcome the fear of math by learning the concepts clearly. In this session, let's discuss about the chapter quadratic equations and the numerical. What we are going to solve is a statement problem, and the numerical is a pole is to be erected at a point on the boundary of a circular park of a diameter 13 meters in such a way that the differences of its distances from diametrically opposite fixed gates A and B on the boundary is 7 meters. Is it possible to do so? If yes, at what distances from the two gates should be erected? This numerical is a part of CBSE as well as NCERT for 10th standard mathematics. I am your trainer Venkatesh K. Now let us see how to solve the problem. So here the expectation is that a pole is to be erected on the boundary of a circular park of diameter 13 meters in such a way that there are two diametrically opposite gates which are fixed. The gates are A and B on the boundary. So the distance of the pole from both the gates should be in such a way that the difference of its distance from both the gates would be 7 meters. First of all, we will have to assess first to convey whether such sort of a condition can be satisfied. If yes, then what are the distances of the pole from the two gates? This is what we will have to find out. So this numerical is from quadratic equations. So satisfying these conditions, we will have to build a quadratic equation and then solve it to find the required distance. That is, now we will see how to do that. Suppose let us consider a circular park. Suppose this is a circular park and there are two gates which are diametrically opposite. That is, let the gates be named as A and B like the way what he is giving. So at A and B there are two gates, that is these two gates which are diametrically opposite. Let us connect the diameter. So he says that the diameter of the circular gate is 13 meters. Let us note down that the diameter is 13 meters. Now we will have to erect a pole at a point on the circumference of the circle such that it is at some distance from both the gates. Now suppose pole is erected here, that is it is at some distance from the gate A and also from gate B. Also let us name the point at which the pole is to be erected as point P. Now what is he saying? He says that the distance of the pole from both the gates is such that if AP and BP are subtracted, we would be getting 7 meters. So this is what is the given condition. Now whatever we have explained till now, let us note down. That is, let P be the required position of the pole on the boundary of the circular park. This is the first entity. Also let A and B be the two diametrically opposite gates as given. Also let P be at a distance of x meters from gate B, that is BP is equal to x meters. Now what is he giving? He is giving a condition which says that difference of the distance of a gate from the two diametrically opposite fixed gates is 7 meters. That is AP minus BP, if we take, then it would be 7 meters. Also it is given that the difference of the distance of the pole from both the gates, that is AP minus BP, is equal to 7 meters. So we have just now assumed the distance of the pole from gate B as x meters, that is AP minus x is equal to 7, or upon transpose of minus x towards RHS, we would get AP is equal to x plus 7. So these are the entities what we have noted down from the diagram which is given here. Also, in order to build the condition, a quadratic condition, we will have to understand a certain concept related to the angle subtended by a chord with respect to center and also with respect to its circumference. That is, if there is a circle with center O, now let us consider a chord here. The chord which is orange colored, so it subtends certain angle with respect to the center O. Also on the same side, the chord is subtending some angle with respect to the circumference. Now, we have studied a theorem in our earlier classes, that is in class 9, which says that what the amount of angle subtended by the chord with respect to center and with respect to its circumference on the same side. So with respect to center, it would be double. That is, the chord would subtend an angle of 2 theta here. Suppose if it is subtending an angle theta with respect to its circumference. So with this, now coming back to our diagram. So here AB is a diameter and also it is a chord. So it is a special type of a chord in which is passing through the center. Since this chord passes through the center, it is called as a diameter. So chord AB, since it is passing through the center of a circle, so it subtends an angle of 180 degrees with respect to center. That is, the chord is subtending an angle of 180 degrees with respect to center. Now, by using the concept what we have seen just now, so it should subtend an angle half of what it is subtending with respect to center. So here, diameter AB would subtend a right angle with respect to its circumference. That is, angle APB is equal to 90 degrees. So just to reiterate, diameter AB is also a chord. It is a special type of a chord which is passing through the center. Since it passes through the center, chord AB is subtending an angle of 180 degrees with respect to center. Now, using the concept what we have seen just now, because the chord, whatever angle it subtends with respect to center, half of the angle it would subtend with respect to circumference. Since it is subtending an angle of 180 degrees, it would subtend a right angle with respect to the circumference. Now, therefore, angle APB is equal to 90 degrees. Since angle APB is equal to 90 degrees, also BP we have assumed as X and AP we have found out as X plus 7, and the diameter AB would be the hypotenuse of this right angle triangle APB. Therefore, we can apply Pythagoras theorem here. That is, by Pythagoras theorem, AB square is equal to AP square plus BP square, or AP square plus BP square is equal to AB square. So, AP is what we have already found out as X plus 7. Here BP is what is assumed as X, and AB is equal to 13 is what is given. Therefore, X plus 7 whole square is equal to X plus 7 whole square plus X square is equal to 13 square. That is, here this term looks like an algebraic expression A plus B whole square. So A plus B whole square is equal to A square plus B square plus 2AB. That is, here wherever there is A in the formula, there is X, and wherever there is B in the formula, we have 7. So in RHS, we will have to replace A by X and B by 7. That is, X square plus 7 square plus 2 into X into 7 plus X square as it is equal to 13 square is 169. So this is what we have got. Now let us simplify this. So here we have X square and X square twice, that is 2X square, plus let's rearrange the terms in decreasing order of its power, that is 2 into x into 7 is 2 7s are 14, 14x plus 49, and transpose of plus 169 would be minus 169 is equal to, on RHS we would be having 0. That is 2x square plus 14x, these two terms would remain as it is, whereas plus 49 and minus 169 would get simplified. So that would be minus 120. So 2x square as it is, 14x as it is, whereas plus 49 minus 169 have got simplified, that is minus 169 is minus 120, consider taking this 49 out. So now all the terms are having 2 as a common factor, that is all the terms are even. Let us take 2 as a common factor, that is 2 into x square plus 7x minus 60 equals 0. So dividing by 2 on both LHS as well as RHS. So on LHS, what do we get now? Dividing by 2 on both sides. So 2 would be cancelled on LHS, and on RHS 0 divided by 2 is 0. So we have got the equation as x square plus 7x minus 60 equals 0. Now this equation looks like the standard form of quadratic equation, that is ax square plus bx plus c equals 0. Now in order to simplify this further, we will have to first assess whether the condition what is expecting us to solve, whether this condition is practically possible or not. That is, it is practically possible if the real roots exist, or if the real roots does not exist, then this condition itself is not possible. In order to find that, let us find the discriminant for the given equation, that is comparing both the equations. So we see that wherever there is a in standard form, we have no coefficient, which means a is equal to 1, and also b is equal to 7 and c is equal to minus 60. That is a, b and c values we have found out here. Now let us find out the value of discriminant. Discriminant is equal to b square minus 4ac. So substitute the value of a, b and c as a is equal to 1, b is equal to 7 and c is equal to minus 60 in this discriminant equation. So upon substitution, b square is 7 square minus 4 into 1 into minus 60. So b square is 7 square minus 4 into 1 into minus 60. So 7 square is 49. Minus into minus is plus. 4 6 are 24 followed by 0, that is 240. So 240 plus 49 is 289 with a plus sign. Since discriminant is greater than 0 here, therefore real roots exists. Real roots exist. Now to answer the part 1 of the question, which is whether this condition is possible or not. So this condition is possible. Now we will have to find out part 2 of the question, which says at what distance from the two gates should the pole be erected. Now let us see how to do that. Let us take the equation what we have simplified as x square minus plus 7x minus 60 equals 0, and then start factorizing it. That is, to factorize, let us multiply the first and the last term. Upon multiplication, plus x square into minus 60 would be minus 60 x square. That is, the two factors what we are going to select, upon their multiplication we should get minus 60 x square. Also now the middle term, that is plus 7x, we should, upon addition or subtraction, we should be getting plus 7x. Now in order to satisfy this condition, 12 5s is 60, 12 into 5, and 12 minus 5 we would get 7x. In order to get plus 7x, let us take plus sign for the bigger number, that is plus 12 and minus 5x. So plus 12x and minus 5x, because the bigger number is having plus, so the answer would have plus. Also they would get subtracted because of opposite signs. Now in order to check the second condition, that is upon multiplication of plus 12x and also minus 5x plus into minus is minus, 12 5 is 60, x into x is x square. Therefore, both the conditions of upon addition or subtraction plus 7x we are getting, and also here upon multiplication we are able to get minus 60 x square. Now let us split the middle term, that is plus 7x, with the two factors. So here the equation is having three terms. Once we start simplifying, it will initially have four terms. That is, let us replace the middle term with the two terms, two factors what we have selected here. That is, the middle term plus 7x would be replaced with plus 12x and minus 5x. That is what we see here. That is x square plus 12x minus 5x minus 60 equals 0. Now, in order to simplify, let us take common for first two terms and also last two terms. That is, out of x square plus 12x, we see that x is common. Upon taking x as common, from x square x is left, plus 12 is left, minus out of the third and fourth term minus 5 if taken common, this would be x plus 12. Now we see that x plus 12 and x plus 12 is common between the next two terms. That is x plus 12 in the first term and x plus 12 in the second term also. Therefore, if x plus 12 is taken common, so from first term x is left, that is what we see here, and minus 5 is left from second term, that is what we see here. So here multiplication of two terms is equal to 0, which means either first term is equal to 0 or second term is equal to 0. Now to simplify, let us open the brackets, that is x plus 12 equals 0 or x minus 5 equals 0. So upon transpose plus 12 towards RHS, we would be getting x is equal to minus 12. So here minus 5 upon transpose we would get plus 5. That is x is equal to minus 12 or x is equal to plus 5. So therefore, these two are the answers which we have got by simplifying this particular equation. But since x is the distance of the pole from the gate B, it cannot be negative. So therefore, negative value of x cannot be considered. So x is a physical dimension, that is, it is a distance of the pole P from the gate B. So this cannot be negative. Therefore, the negative value of x cannot be considered. That is, the pole should be erected at a distance of 5 meters from the gate B. Also, the distance from the gate A would be, that is, BP is equal to 5 meters. That is, similarly, now the distance of the pole from gate A is x plus 7. That is, let's find that out. AP is equal to x plus 7 or AP is equal to 5 plus 7, that is AP is equal to 12. Therefore, to conclude, so here the pole P is to be erected 5 meters away from the gate B and the pole is to be erected 12 meters away from gate A to satisfy the given condition of erection of a pole for a circular park. This completes the solution. Thanks for watching the video. Take care.